Welcome to The Explainer. Today, we're diving into something that tackles one of the most universal pull-your-hair-out headaches in modern software development. If you build applications, you know exactly what I'm talking about. Integrating APIs across incredibly diverse tech stacks. You've got a backend built in one language, a web front end in another, mobile apps in a couple more, and maybe some cloud automation scripts in yet another. Keeping all of those client integrations in sync every time your API changes, it's a massive, time-consuming grind. But what if all that friction could just disappear? Just consider this staggering reality for a second. 15 native integrations, exactly one source of truth, and absolutely zero handwritten SDKs. Let that sink in. We are talking about literally eliminating an entire category of manual repetitive work while actually improving the quality of your code at the same time. Okay, let's look at our agenda for today. We'll start with the SDK maintenance trap, then move into a much lighter approach. After that, we'll unpack how you get 15 languages with zero manual SDKs, look at native capabilities end-to-end, and finally wrap up with the architectural advantages at scale. All right, Section 1, the SDK maintenance trap. Let's talk about the heavy burden of the traditional way of building client integrations. If you look at the usual way of doing things, the amount of multiplying work is honestly just exhausting. You typically need a separate SDK repository and a parallel release train for every single platform. You're syncing spec files by hand, dragging heavyweight code generation toolchains into every build. And the worst part? Server changes often surface as latent runtime failures. It's fragile. It's heavy. But then there's the much-needed relief of the Add ServiceStack Reference approach. You run one simple command against a running API. You get a single generated source file per client. There's absolutely nothing to install or configure on the server. And breaking changes, they're caught immediately by the language's own tools. It's a total game changer. This quote really hits the nail on the head. Traditional SDK development multiplies work. Think about it. A single, tiny change on the server usually creates a massive domino effect of manual maintenance across an entire fleet of clients. Someone adds a new property to a backend model, and suddenly you're updating wikis, tweaking JSON parsing logic in Swift, updating a TypeScript interface, and just hoping the Python automation scripts don't randomly break. Moving on to Section 2, a much lighter approach. This is where the contract itself actually becomes the product. The core idea here is incredibly simple. Stop rebuilding the exact same API for every single platform. Because a ServiceStack request DTO, that's data transfer object, already knows its own response type, its route, its HTTP method, and all its validation metadata, well, that intelligence can be carried directly into every client. You aren't just passing around anonymous JSON objects and guessing at their shape anymore. The generated file literally is the contract. So this builds into a remarkably simple 4-step workflow. First up, you define a typed request DTO. Second, you implement it just once on the server. Third, you refresh the reference in any client. And fourth, you call the API using native types. And that's it. There's no parallel release train, no massive schema translation layer, and absolutely no drift between some outdated wiki document and the API that is actually deployed. And getting those contracts, it's incredibly flexible. This workflow adapts entirely to how you like to work. You can generate these natively right from your terminal using a quick npx get DTOs command. Or if you prefer to stay in your editor, there's IDE integration for Visual Studio, Writer, IntelliJ, Android Studio, Xcode, and VS Code. You can even read the DTOs straight from the API URL in a web browser. It requires absolutely zero heavyweight installations or weird configurations on the server side. Okay, part 3. 15 languages, zero manual, SDKs. Now, what's really interesting here is the visual proof. I mean, just think about the sheer scale of this for a minute. C#, TypeScript, JavaScript, Python, PHP, Ruby, Swift, Java, Kotlin, Dart, Go, Rust, and Zig. Running one command against a running API provides end-to-end typed integrations for 15 of the world's most popular languages. And what comes back is definitely not some generic JSON dump. Now, for the skeptics out there who might think this is just a basic HTTP wrapper, it's really not. When you compare the generated TypeScript and Rust outputs, it's obvious how deeply idiomatic they are. In TypeScript, you're getting clean ES imports, familiar async await patterns, and standard class instantiations. And then over in Rust, the generated code uses idiomatic vec macros, optional sum wrappers, and distinct Rust traits like default.default. The output completely respects the style and conventions of the target language. We see that exact same level of native polish when we contrast Swift and Go. Swift developers get clean foundational classes and native exception handling with try. Meanwhile, the Go-generated code naturally fits right into its own paradigm, utilizing Go modules, multiple return values for idiomatic error handling, and struct literals. The generated client naturally feels at home in entirely different programming paradigms. It really feels like it was hand-built by an expert. So, here is the absolutely crucial takeaway. You get native classes and generic typed clients that already know exactly how to call them. Because of this, developers get intelligent autocomplete and editor completion while they're actually building. And even better, they get compiler feedback immediately when contracts change. Your language's own compiler effectively becomes your automated integration test. Which brings us to Section 4, Native Capabilities End-to-End. We're moving way beyond basic HTTP requests here. The consistency across these 15 languages is pretty incredible. You aren't just getting typed requests and responses. You're getting structured field-level validation errors in a common shape across every single language. You get built-in authentication, handling bearer tokens, API keys, session cookies, the whole shebang. You get typed autoquery for rich data APIs without manual paging plumbing, and full support for multi-part file uploads. All of this behavior lives in the client. It's entirely reusable and doesn't have to be painstakingly reinvented by every single team that wants to use your API. But what if you need to tweak the output? Well, it's brilliantly simple. The generated files start with a header containing the options used to produce them. Developers can simply uncomment options directly in that file, say filtering out specific types or changing namespaces, and then just rerun the local command. The output changes per client entirely on demand without ever having to touch or redeploy the backend server. Finally, Section 5, Architectural Advantages at Scale. Let's zoom out to the macro perspective. When you're operating at scale, your API contract acts as a safe, definitive boundary between teams, applications, and release schedules. Because the deployed API dynamically publishes the contract, consumers just refresh it on demand. Because behavior like auth and error handling lives natively in the client, you prevent tons of duplicated effort. But most importantly, it allows an organization to be truly polyglot without the usual fragmentation. Every team can use the language best suited to their specific product, while the backend remains perfectly consistent. So how does this play out in the real world? Brilliantly, actually. A single backend can seamlessly power a TypeScript web app and Swift or Kotlin mobile apps, all sharing the exact same precise typed contract. At the exact same time, you can have Go workers automating operational APIs, high-performance Rust desktop software consuming authenticated services, and legacy Ruby or Python business systems tightly integrating. And all of this happens without the team ever needing to maintain a separate handwritten SDK for a single one of them. It all summarizes perfectly into this core philosophy. Your API should speak your developer's language. You build and define your contract once on the server, and you effortlessly reach everyone, everywhere, in the exact syntax they're most productive in. Build once, reach everyone. So I want to leave you with a final provocative thought as we wrap up this explainer today. If your backend APIs are already meticulously typed, why aren't your cross-platform integrations? It might just be time to rethink the friction in your current API integration process and let the tools do the heavy lifting for you. Thanks for joining me on this deep dive, and keep learning.